Hey folks, it's Graeme Cox from Australia, and I want to share with you something that we discovered several years ago that is saving us and our clients millions of dollars in earthworks, and we've only just started. Over the next decade, we expect to save hundreds of millions of dollars in earthworks, and with those earthworks, increase farm incomes by billions of dollars. Yes, I know, sounds like a lot of hype. I mean, hundreds of millions and billions of dollars? Well, frankly, I wouldn't have believed it either if I hadn't seen the results with my own eyes. But it's been already proven over thousands of acres around the world in all kinds of crops, conditions, over and over again. Now, before we get into the details, I want to set the background to why we do on-farm earthworks in the first place. It comes down to managing the most critical variable on almost all farms. Numerous studies in all sorts of crops, soil types and land types and climates all indicate one factor has the greatest impact on crop yield and farm profitability. And that is, any guesses? Fertilising, varieties, crop rotations? No, it's water. Good old H2O. Yes, water is the most important factor affecting farm profitability from year to year. Too little water and too much water leads to a myriad of compounding problems. To highlight this point, here is a quick scenario. So you're ready to start your planting season, but you get 4 inches of unseasoned rainfall overnight. You delay planting for weeks, waiting for the depressions in your field to dry out. In this delay, you lose 10% of your yield potential because you are not planting in your best time window. You get more rainfall towards the end of planting, but you press on in the wet conditions, compacting your soil, using more fuel, getting bogged and damaging your machinery. Then the crop starts to come up, but at different times and with different vigour, due to the variable soil moisture and waterlogging in some areas. Next, you spend hundreds of thousands of dollars on fertiliser only to see some of it go up in the air due to waterlogging after another significant rainfall event. Then in the weaker spots, weeds start to get ahead of the crop and disease and insects break out that have thrived on the saturated soil conditions in the wet areas of the field. You spend more money spraying herbicides, insecticides and fungicides with limited effect. Finally, you're getting towards harvest, but the weather forecast is for more rain. You can't sleep at night because you have forward sold the crop and yields are not looking promising. As you lie in bed awake, the rain starts to fall, almost like your worst nightmare. Harvesting is delayed and the crop quality is downgraded. You need to get a contractor in with wet weather harvest gear to finish off the harvest, costing a lot more than normal. Yields are down 30%, costs are up 20%, and you can't deliver all your forward price contracts, so you need to buy some back at the top of the market. You are dreading a meeting with your bank manager and are actually very worried. Now, this type of season might not happen very often, but they do happen, and when they do, they can send a farm broke. We had a year like that in Australia a few years ago, and after years of drought, it was devastating. Now, this scenario doesn't even touch on drought and irrigation, and that brings in a whole lot of more issues. So you can see now why I believe water is the most crucial factor in farming. So how can we better manage water? Well, we can't control rainfall, but we can remove excess water, and this is called drainage. We can also promote uniform infiltration of rainfall and irrigation water. Let's lump these together and call them water management. So there are numerous ways to improve water management in your fields. You can put in drains and ditches, levees, subsurface drainage such as tile, but our preferred method is land grading. Land grading, also called land levelling and landforming, is the reshaping of the surface of the land with tractors and scrapers to planned grades. Its purpose is to provide good surface drainage and promote uniform infiltration of water. But in this video I want to talk about a new method of land grading. Now, I've never presented this material in public, I've only taught it to some of my closest clients, but this video is what it's all about. It's called Optimum Surface Landforming, often shortened to Opti-Surface. Now that may sound weird or mysterious, but it's pretty simple, and we're going to make everything clear here. So I've got my whiteboard, so let's go for it. First, let's talk about the old style of land grading. Well, this is my fancy depiction of land grading. I'm sure you've heard of laser levelling or laser grading before. This is where you take a laser and you set it up in the middle of the field, and it sends out a beam of light that creates a flat reference plane that the earth moving equipment with a laser receiver can use as a reference plane. To do a good job of laser grading, you need to survey the field elevations first and calculate the best slope to minimise the earthworks and balance the cut and fill amounts. Now, laser grading was invented in the 1960s and 70s and was a great innovation. It actually started as laser levelling, and that's why everyone refers it to laser levelling. It started in rice and dead level irrigation basins in Arizona, where growers wanted to pour water onto a field and have a uniform depth across the bay and let the water infiltrate. So zero grade from one side to the other, no slope. Now this works really well in rice because you want to pond the water. And it can work well if you're irrigating in the desert and you don't have to worry about getting excess rainfall off the field. But for most crops and surface irrigation methods, you want to have some slope to get the water to move on and off the field. So next, the laser developers added the ability to set the laser up on a defined grade to ensure the water will flow from one end to the other and drain out. Now lasers work in this application, and millions of acres have been laser graded around the world to great effect. And you know what? My Opti-Surface partner David Cox has used laser grading since the 1970s, and it has been very effective for him. In fact, he developed 7,000 acres of our family's swampy, second-rate cattle land into one of the most productive furrow-irrigated farms in the world by shifting almost 2 million cubic yards of soil with laser grading. So laser grading does work and it can be effective, but for most agricultural applications it is an overkill because you don't need straight-line grades to get the water management outcomes you want. So there is a time and a place for laser grading, but in general, the old-fashioned laser grading is not the best way to go. So let me tell you how we came up with this concept. David spent thousands of hours in a tractor seat shifting earth using lasers, and he was often frustrated when he could see the natural slopes of many parts of the field were consistent and falling in the right direction, but the laser design indicated that lots of soil needed to be moved to fit the straight grades of the laser and to get the cut fill soil volume to balance the field out. Actually, I'll let David tell you. Now this video is a couple of years old and you'll have to excuse his mean look. He has a black eye and had recently had surgery to fix a fractured cheekbone. I won't go into the details, but here he is.
I've been developing sugarcane or land for sugarcane farming since 1970. I did not start growing sugarcane until 1987, but I became the importer and marketer of laser levelling technology for the sugar industry in Australia in 1979. I was extremely impressed with laser technology at that stage. The ability to be able to landform with tolerances of plus or minus 5 or 6 millimetres was a great step forward in irrigated agriculture. But after a decade of capturing those benefits, of course we get frustrated with some of the shortcomings. And shortcoming with laser technology is that laser light travels in a straight line, and most of the Earth's surface is not straight. It is either a convex or a concave slope. And so I had a dream to come up with a software program that we could design a farm with these slight curves to allow the design to more closely follow the natural surface, while still achieving the objectives that we wanted, that is drainage and a general smoothing of the field surface to allow for good speed and efficient farming operations. Another major objective was to minimise the amount of topsoil that needs to be shifted in any landforming undertaking. So I came up with a concept and put it to a US company to develop my concept, and that wasn't achieved. I then approached my nephew Graeme and explained what I wanted to achieve and asked him would he consider taking it on. He did, and after, my recollection is around 9 months, Graeme rang me in the middle of the night and said, yes, I've cracked it, and he's achieved what I wanted to achieve, to be able to have variable slopes in a field, but not changing slopes at a hinge. So, whereas laser now we have the technology allows us to do straight lines, a hinge and another straight line. No, we had achieved being able to develop a slight curve. The other instruction that I gave Graeme while I was prepared to vary the slope within a field from, if an average grade was, for example, 0.1%, I wanted to be able to let the software allow the grade change to be a margin either side of that average. For example, if the average was 0.1%, I wanted the ability to say to the program, if the land surface either side of it, somewhere else in the field, is as steep as 0.15, allow it to be that steep. If it's as flat as 0.06 or 7, allow it to be that flat. But just smooth it within those constraints. On my farm, I shifted around 500 cubic metres per hectare of soil in the levelling process when I did it 20 years ago. If I redesigned my farm now with OptiSurface, we would be shifting less than 200 cubic metres per hectare. Is a big gain, but then even more important for us, the maximum topsoil shift would have been dramatically reduced. And in our soil types, we have very little topsoil, and so removing it decreases yield for 5, 10, 15 years and possibly more. While I was prepared to accept variable slopes within the one field, I did not particularly want the steepest slope I would accept and the flattest slope that I would accept meeting at a point. So I asked Graeme to come up with something in the program that would allow us to dictate, as the designer, over what distance we would let the land change from the maximum to the minimum slope. I must say, on most of my land that has been OptiSurface levelled now, with these varying slopes, to the naked eye, we can hardly pick it.
So from that, I hope you get a feel from where we've come from and where we're going. The thing that we really haven't discussed is the real enabling technology is high accuracy GPS. Now we have to thank the United States for this excellent tool. It's amazing what it can do, and this is another example of how it's improving agriculture. So what we've actually done is replaced the laser with a GPS, high accuracy GPS. So let's scrub that out. So we've got a GPS base station sitting in the field instead of a laser transmitter, and we have a GPS receiver on the bucket instead of a laser receiver, and the base station is communicating with the GPS receiver on the bucket to get high accuracy control. Now when we talk about high accuracy, we're talking about in the vertical, ideally we want it less than half an inch, and we're seeing that in the field. Now the brilliant thing about it is that now we're not restricted to a single plane that the laser restricted us to. We can have any three-dimensional surface that we want to landform to. So once we had the high accuracy GPS, the missing part of the puzzle was the software to design the surface. So basically that is OptiSurface landforming. So this does not have to be restricted to where laser grading was effective anymore, like furrow irrigation. In fact, their biggest clients are using it on land that is not irrigated, but they have problems getting excess water off the field after rainfall or snowmelt. I've done designs for many non-irrigated fields, and my clients have too, and this stuff just plain works. And because you're avoiding large soil movement and excessive topsoil movement, that's why it works in so many areas of agriculture that lasers didn't. In all kinds of crops like wheat, sugarcane, cotton, corn, soybeans, bananas, blueberries, grapes, sorghum, furrow irrigated, drip irrigated, centre pivots, non-irrigated, flat topography, undulating topography, on and on. I could probably name 100 different types of applications where OptiSurface has worked. Now you don't need to be an expert to do this. In fact, it's probably easier than using laser grading. And you don't need big farm. We have clients using it on 1 acre fields up to 1,000 acre fields. So that is OptiSurface landforming. I hope it's given you a good overview of the system. Now I've got a few more videos coming for you. In the next video, I'm going to take you on a deep dive into the whole OptiSurface world. I'm going to show you examples and case studies and exactly how we can get the earthworks down so low. So stay tuned. In the meantime, tell me what you think about this concept, and more importantly, how you could use it in your business, or any questions. Just scroll down below this video and start typing in the box. We would love to hear from you.